So today we are going to design the three address code for the Boolean expression. Here you can see a Boolean expression p greater than q and r greater than s or t greater than u. So we are going to design a three address code for these type of Boolean expression. If I ask a question, what this Boolean expression gives the result, so it depends upon the value of p, q, r, s, t and u. Suppose if this condition is true, so we can say that the result of this statement is 1, otherwise 0, and same here, r greater than s, if condition is true then result is 1, otherwise 0, and if t less than u, then if result is if the condition is true then result is 1, otherwise 0. And after that, if 1 perform AND operation with 1, so the result is 1. Okay, and if this is 0 and this one is 1 maybe, so the final result between AND operation is again 0, and similarly we will perform an OR operation. Okay, and second thing, in this expression, if I talk about how many operators use and what is these precedence, so this is a relational operator, this is a relational operator, and this is a relational operator, and this one is a logical operator, and this one is a logical operator. So according to precedence of an operator, the first precedence is provided to this relational operator, the second precedence is for this one, third precedence is for this one, fourth precedence is for logical operator and the fifth precedence provided to OR operation. Okay, so we will follow these system, and by which we are going to design a three address code for a Boolean expression. So let's start designing of a three address code. So our first task is to calculate evaluate p greater than q or not and store its value in a compiler generated temporary variable. So for this thing we are going to write a statement if p greater than q, because we are going to evaluate this expression. So if p greater than q, then perform a go to level where we are going to store the value of we are going to store the value of p greater than q true or false. If the result is true, so we will assign a 1, otherwise 0. Okay, so I will define this level later, because I have no idea right now how many three address codes are used. Okay, and I have already told you that whenever we are using a if statement, so the just next statement is treated as an else. Okay, so it means if p greater than q is not true, it means the value for this expression is 0. So here I am storing this one as like that, t1 equals to 0, because I have assume or we have a plan p greater the value of p greater than q we will store in a compiler generated temporary variables t1. So here I have used a t1 equals to 0. The next step is that if you have decided p greater than q's value is false, means t1 value is 0, so our next task is to perform r greater than s. Okay, so we will move our control from this statement to another statement where we are evaluating r greater than s. And the next three address code is a fourth step, defining a fourth step. So here right now we are defining the level of p greater than q and go to level 4, and here I am assigning a temporary variable t1 a value 1, because at that time p greater than q condition is true. So we will follow these system to evaluate the value of p greater than q. Similarly, we will evaluate another relational operator r greater than s and define its go to level. And here you will mention a level 5th, because after storing the value of t1 equals to 0, your control move here, because if this is decided p greater than q is false, so the result is t1 equals to 0, and simply control move to evaluate another expression. The same system is follow here because this structure is valid only for p greater than q. Okay, so here you can easily see that. And if we will follow a same structure, so here you can again see that uh, t2 equals to 0, because uh, to store the value of this expression we will use a compiler generated temporary variable t2, and for p greater than q we have used a t1. So t1 equals to 0 here, and again define a go to level. You can easily correlate after storing after storing a value of t1 by 0, uh, we will move another statement, and that is this one. So similarly, after evaluating r greater than s and store its value t2 equals to 0, our control moves here t less than u. Okay, so we will follow a same system. And if r greater than s is true, then our go to level moves here, because in this statement I am going to assign a value 1 to temporary variable t2, and in the ninth step we will assign a ninth level here because our control moves here, and we are going to evaluate another expression t less than u. So here you can easily say that t less than t less than u, and its go to level is, I will again define later. And after that, suppose if condition is false, so again we will assign a compiler generated temporary variable t3 with a value 0, and control moves a next step. Okay, and suppose if condition is true, so we will assign another level 12, and where we are going to store the value of t3 as a 1. So this is the evaluation process for r greater than s, and this is the evaluation process for t less than u. You can easily understand what I am saying. And after that, if our result means this expression is already evaluated, this expression is already evaluated, and this expression is also evaluated, and the value of this expression is stored into a compiler generated temporary variable t1, the value of this expression is stored into a compiler generated temporary variable t2, and value of this expression is stored into a compiler generated temporary variable t3. So now our task is to perform a AND operation. So how we will perform a AND operation? So here you can see that t4 equals to the value of this expression is stored into a t1, and the value of this expression is stored into a t1. So our task is to perform a t1 and a t2 and store its value into the another compiler generated variable t4. Okay, and after that our next task is to perform a OR operation. So here you can see that the value of this and this is stored into a compiler generated temporary variable t4. So at that time I am going to use another compiler generated temporary variable t5, and the value of this expression is stored into the compiler generated temporary variable t4 OR, and the value of this expression is already stored into a t3. Okay, so here you can see that this is the final answer.